Hello and welcome to another tutorial. So this time we are going to be taking a look at creating a couple of simple effects in shader graph. So the two ones that we're going to take a look at is being able to create kind of a burning dissolve effect, something where the object sort of fades away, but we have these sort of edges to it that are brighter and it fades away in patches. So we're going to be setting up that. The other thing that we're going to be setting up is a system for having an object not exactly fade out, but have it essentially dither out, so clipping out portions of it based upon how close it is to the camera. And we'll actually set both of these up so that they are a reusable chunk we could add into other shaders, but we will also integrate them into the one shader. So let's dive right on in. So I've already got a basic scene here, and I also already have a very simple shader graph set up. So this is a fairly basic shader graph. It is a lit shader. We're using the universal pipeline here. And with this, what I'm doing is it's just currently got support for texture, so an albedo texture and a normal texture. It's got both of those in there. And it also, one of the things that I did change is I turned on alpha clipping, because this is how we're actually going to be performing the stuff where gaps and things like that appear in it, is going to be by using the alpha clipping component there. Because what this will do is we set a threshold, and anything where the alpha value is below that threshold gets clipped out. It won't get rendered. So that's how we can achieve this. So we're going to get started with this. So there's going to be a few things that we are going to need. So the first thing we're going to do is the dissolve one. And you can see I've actually already set up the parameters here. So we've got this progress value, which can go from 0 to 1. We have the edge depth. So when it's doing the dissolving, it will fade out in patches. We want to be able to control the size of the sort of edge there. So how sort of illuminated, how bright that is. We want to control the color for that, which I'm going to, let's make the default color for that. Let's go for a really sort of orangey color at the moment. That'll work. So we've got our edge color, we've got the noise scale. So what we'll be doing is, to do this fading out, we're going to generate some noise. You could also use an existing texture. In this case, I'm going to just generate noise using Perlin noise. And what I will do is, so Perlin noise gives us a value that goes from 0 to 1. We can use that. If we then have the progress one also goes from 0 to 1, we can have it that as our progress goes up, anything in that noise texture that is below that progress value, we clip out. So at 0, everything is going to be included. It's going to draw everything, but as it goes up, there'll be more and more that gets included, because something like Perlin noise is sort of smooth and uniform there. It works quite nicely for creating these little sort of holes and pockets there in it that looks really cool. So let's start actually getting this set up. So, okay, first thing we need to do is we need to generate our noise. So under create node, we do have different noise options. So I'm going to, in this case, use simple noise, which corresponds to Perlin noise. I want to be able to control the scale of this, because that's going to give us a little bit more control over it. So we've got the scale coming in, and I need UV coordinates. Now I've already got my UV coordinates up here, so I can bring these down. So, okay, that's sampling that noise texture. So I've now got that threshold that I can be comparing against. So what I want to do then is, so I've got that threshold goes from 0 to 1. And what I want to do is I want to get the difference between that value of the noise texture and our progress value. So if I bring in dissolve progress, I can do a subtract, and I am subtracting the value from the value of the noise texture. I'm taking away our dissolve progress from that. So what that's going to mean is any values below dissolve progress will be negative. So anything that is 0 or below should not be rendered. Anything that is above that should be rendered. So it gives us a really clear sort of threshold. So what that then means we can do is, well, we've got effectively a bit of branching of behavior here. Now, we can get away without using an if, and we ideally want to. If we can avoid using branching, that's always good. So we can use our step function here. So we use step, and now the edge defaults to 1, but we want it to be 0. So what will happen with this step function is any values where the value we've sampled from the noise texture is below the progress, subtract will make that be 0 or negative. With step, that will then come through as 0. So step is giving us a 0 or 1 for should something be rendered. If it should be rendered, it will come through as 1. If it shouldn't be rendered, it'll come through as 0. So that is actually something that we can just directly feed that in to our alpha value. So if I save this, and then I can select that material, and I'm going to fix up the dissolve color here. We can reset that as well so it's got the correct value. So if I update the progress here, you can see it starts to fade out. I can also see what happens if I change the scale. So if I make the scale larger, we get sort of smaller little pockets. If I make the scale smaller, we get much larger ones. So it's down to what we want appearance-wise for that. But, so we've already got it doing the cutting out there, which is cool. So, okay, that's good. But we want this highlighted edge there. That's another thing that we really want to have with this. So that's okay. That's easy for us to do. Because the value that we've got here, if it's above 0, then it might need the highlighting. And how far above 0 it is, that actually corresponds to effectively the distance from that edge. And we can treat it like that. So that means 0 up to our edge depth is the section we want to highlight. So what we can do is we can check if this is above or below the edge depth using our step function, where the threshold we use is our edge depth, just like that. So I'm going to actually bring this up to here and move all of this down. So what this will give us is if it is the output from this is 0, then we should draw the edge. If the output from it is 1, then we just draw the regular color. So this is where we can use a lerp. So I can do a lerp, and the input here, that value is going to be our t value. If it's 1, then that means that we just draw the normal color. So that means if it's 0, we use the dissolve edge. Otherwise, we can grab our color here and link it over. So that is now going to generate the correct sort of appearance there, where we've now got a color coming out of here that is either going to be our base color or is going to be the edge color. So that's great. We can then take that, and what we can do is link that over into our base color here. And then if we save this, then what we'll see as we ramp this up. So we're not really seeing anything yet, but that's because our edge depth, 0.05. So we need a bit of depth there to it to be able to actually see it. And if we zoom these in, we can kind of see a little bit clearer. So, okay, that's pretty good. We've got that working. What would be nice is if this was a little bit brighter though. So that's something where we can chuck a little bit of emission on our edge here as well. So that's where what we could do is we could actually do another lerp where again it's using this same value here as the T1, but the difference in this case is we'll move both of these up because there is a very big difference, and the big difference in this case is, so this one, we still connect the dissolve edge color like that, but our color here, we actually set it to be all zeros. So it's lerping, it'll either be our edge color or it will be a fully transparent black color, so essentially having no effect, because we can then link that up to our emissions setting here, and we can save that. And then these are now much brighter, and if we look at it here in the scene, you can see those look much brighter, and we can mess with the edge depth there depending upon how sort of the visual effect we're after for it, but it gives us a really cool appearance there for it. So that's pretty cool. We can also, we could have it the noise here, because we're sampling the UV values there. We could actually have that noise slightly shift if we wanted to. So we could set up something where we have, let's chuck in dissolve noise speed, which is initially going to be 0. Going to grab time. I'm going to multiply time by the noise speed. So now we have a version of time that is scaled. So we've got a version of time that is being scaled, and our UV coordinates, we can then be adding to those. So I could drag from here, do an add, and then what I'm adding in is whatever the value is from time, and link that up to the UV coordinates. Because what will now then should happen is if we want that noise to be in motion. So at the moment, there won't be any motion to it whatsoever. So if I set it like that, it's completely static. If I set it running, so we've got consistent updating of the time here for it, then the noise speed, set that to 1. It's really rapid. I could set that to be a much sort of slower value. So if we want it to move, we've got the ability to control that. We'll set it back to 0 for now. So we've got our simple sort of dissolve noise happening. So what I'm going to do is I'm going to take this and I'm going to convert this to its own little subgraph. So to a subgraph, so this is going to be dissolve subgraph. This then means it's a handy little thing that I could reuse in anything if I wanted to. And we've got our different settings coming through, which is cool. Now, one thing when we do a conversion like of this, it doesn't remember the names of things, so that's something where we often need to go and update that. So the out vector 1 is alpha. The out vector, that first one, is our albedo. So we can update that. Albedo and emission. That just sort of keeps it neat and tidy. We also need to name these input ones as well. So in this case, this vector 4 was input albedo. Just so we've got that properly all named. It does make it then a little bit easier for when we are working with this. Just so we've got stuff consistent. And neaten up the positioning of all of these. These are our UV coordinates. UV. So again, it just means that everything has the proper names, because that way then if we're going and reusing this in something else, we very easily can drag this in and we can see exactly the names and everything for it. So, okay, that's cool. We have our dissolve setup going. So the next thing we want to do is we want to be able to have something fade out. And in particular, what we're wanting to be doing is we're wanting to have it that, and you might have seen this in some games, the closer an object gets to the camera, the more it starts to fade away. Now, doing that by lowering the transparency is expensive. Because it means then everything needs to be rendered as a transparent object that supports this. But we also have the option of, like we're using for this, we can use the alpha clipping. So what we need is a way of being able to sort of generate that fading out. And we also need to know our distance of an object. So what I'm going to do is I'm going to create a node, and firstly from the camera, I can get the camera's position, which that's handy. So, okay, we've got the camera position. Now, and I will set it up with this initially, but it's not going to give us quite really the effect that we're after. So when I grab this position, this is going to be the position of the chunk that it's rendering. So it's not the actual position of the object itself, but we're going to subtract these two, and then what I'm going to do is I'm going to get the length of that. So that's giving me the distance of this. So I can get how far this is from the camera. Now, as I said, at the moment, this is going to be how far the chunk that is being rendered is from the camera, and that's okay. So, okay, if it's within the fade distance, then we need to start fading. Otherwise, we do nothing. So anytime you got something where it's like, well, if it's over this value, you do this, or otherwise do this other thing, that's where step function comes in. So going to use our step function, and we've got that. And our edge is the fade distance. So yeah, in general, anytime you've got something where it's like, oh yeah, this seems like I would be doing an if and comparing this value if it's greater than or less than, think step. It's going to be quicker. It takes a bit to get head around it. I still, when I'm writing out the code, tend to always forget which order edge and in go for it, because it's not always autocomplete. So it is really handy. It does actually work really well, but it takes a little bit to get used to using it, which is okay. So, all right, this is going to give me 0 if we are below the fade distance. So that's going to mean we should be fading out. Otherwise, it's going to give me 1. So if it's within that fade distance, I need to work out how intense that fade should be. So what I want to do, not from that, is I want to take that distance and I want to divide that distance by our fade distance, because that now gives me something that, rather than being a 0 to however many meters, I now have something that is 0 to 1, which is really handy for working with something like a VLURP. So I want to work out how much it should be dithering by. So at 0, it's going to be quite essentially almost entirely gone, whereas at 1 it should be very minimal. So I'm going to bring in these min and max dither values. This allows me to sort of control how this is going to actually work. So I can then do a loop between these. So this is going to be giving me the intensity of that dither, because I can then go, and there actually already is a dither function, which the input is what we use here. That input controls this intensity. And if I disconnected this, so that's at 0, 0.5, 0.1. So the lower it is, the more it's going to be saying essentially to emit values. Because what we'll be doing is with the dither, sections that are coming through so it comes through as either 0 or 1s effectively. So 0s we won't render, 1s we do. So we've already got a value that is going to be getting lower the closer it is to the camera, and is going to be 1 when it's right at the edge. So it's a perfect stuff to be feeding in. The reason I have these min and max dither ones is if we wanted to have it that even when it's really, really close, there's still a little bit of visibility, or that gives us that control over it. So, okay, we've got the dither there. So we've calculated the values. We've got our 0 to 1 to indicate whether or not it actually is dithered, so whether we're using the particular thing. So this is again a case where we use a loop. So the step function, so a 1 from the step means that we do render. A 0 from the step means that we use the dither check to decide if we render. So what we do is we bring through the dither. So now we've got something that is either the output is going to be 1 for when it should be rendered, which will always happen if it's beyond the distance, or the output might be 0 or it might be 1, depending upon whether we have the correct value there. Okay, so we have a 0 to 1 value. So then that we can actually, and I'm going to connect this up to our alpha value and then save this. And then we've got our fade distance threshold is quite low there, but we can already see if I back away and start moving towards, you can see it is dithering it out, but it dithers it out by the entire sort of like sections of the object. It's not dithering out particular individual chunks, which is not great. We want to have it that it's dithering out specific, the object as a whole. We don't want it to be dithering out a section of it. Doesn't really look that great. So that means what we need to be doing is we actually need to be comparing the object's position, not the position of the section we're rendering. So what I'm going to do is I'm going to take all of this first and convert that over to a little subgraph, because that's going to make this neater and easier to work with. So what we'll do is we'll go convert to a subgraph, dither fade. That makes this a lot neater. So I really recommend making a lot of use of things like of subgraphs. It keeps everything significantly neater for working with. And then we can just update our output here. That's the alpha. Just keeps everything a lot neater. Like, you can use groups for organizing stuff, and absolutely, definitely make sure you do use groups for keeping things organized. It does make stuff a lot neater. You can also double click on things to change how the wiring gets routed. So to try and keep it, again, just that little bit neater. That one doesn't really add to the neatness. Probably move that there. Always try and keep these as neat as I possibly can, because it is one of the things that can be challenging with visual-based editors, is keeping everything neat and organized is not always the easiest. But what this means is I can then improve my dither fade graph here without needing to mess around with sort of changes to the other one. So the big thing is I want the position of the object, and changing this to object space isn't enough. That's not going to give me that, because it's still going to give me the object space position of the particular thing I'm working on. What we can do though, so let's take a look and see, we do have object position for the scene. So we can take that and connect that in, and we'll see if this is giving us what we need. Otherwise, we do have some other options of how we can actually do this, but we'll check and see, because what we want to have happen is as we get closer, the entire object, and we can see that's starting to, but if I probably need to increase that fade distance. So chuck the fade distance up to 5. So that is working. That fades out the entire thing. If I drop it to 2. So that's nicely fading out. Probably going to end up needing to be something like 3. So there's going to be a little bit of tweaking and adjusting of what it needs to be set to, because there it's just starting. If I drop that to 2, it's fully there. 4, it's probably too far. Something like 3 or 2 is probably about right, actually. And that looks pretty decent. But we did lose our dissolve effect though. But that's okay. We can easily bring back the dissolve effect, because dissolve was giving out alpha. This is also giving out an alpha value. So what we do is we can actually just multiply the 2 alpha values. So if I connect that up like this, what I'm going to do is move that there. And then I will bring this alpha value up, so that then if we save this, the idea is we get something that is a combination of then both. So that then if I move closer to stuff, it starts to fade out. But then while it's fading out, it can also dissolve. So the 2 work together. So that gives us something where we can easily fade out objects as we get closer to the camera. And we do have the option there, if you wanted it to be something that was more based upon fading out a portion of the object, we could do that. That would be something that would be more applicable for if it was a really large object. So this is obviously, if we're working with small objects, it makes sense and looks better generally to fade out just the entire object in one go. But if we needed to, we could change that as we saw to it's fading out a portion of the object quite easily. And then these blocks that we've got, we can easily throw these into any of the other ones that we need. So we could throw this into other shaders that we're working on, and we've got clear little things that we just need to link up for it to control the visual effects there for it. So it gives us some basic simple shader stuff there for this. A couple of things to make sure if you are setting this up to watch for. So in a new shader, alpha clipping will typically not be turned on by default. So do make sure you turn on the alpha clipping option. That is something where you do want to make sure you've got that turned on. The other thing there is you might want the edge color here, the way that actually works, to be picking up off of the current edge color. So that is something that we absolutely could be doing. At the moment, what we do is we just do a direct, it's the edge color is used, but you could actually multiply or blend the edge color with the albedo. And then that's going to give you a bit of something where it's actually picking up off of the current texture there. So if we're wanting to do something like of that, we've got the edge color, and we've got our input albedo, what we would do is, this is where I would actually use something like a blend. I think is a good option for this. We've got the different modes that we could be doing there for it, but if I changed it to something like burn feels appropriate. So we'll switch to that. And we want to make sure we connect up the correct things. So nothing should be directly linked to dissolve edge color now. The dissolve edge color comes from this. We could have a control here, dissolve edge weight, which will make that a one that is just going to default to 1. And this is just going to control essentially how the strength of whether it's using that sort of edge weight or not. So that's good. What I will do is just reorganize this a little bit, try and have it a little bit neater. It's always a challenge trying to keep these nice and neat, but if we can, it's worth it. So what that will mean is back over here in the simple shader, we need to connect up our edge weight, so that's fine. We have a dissolve edge weight. So in this one, we're able to, again, set that to 1, set that to be a slider, and link that up. So now we'll be able to control the intensity of that. The other thing we could then be doing is we don't really have any tint color. So we're going to set up, so we have a tint color. Here, default tint color, usually you want that to be white. That will mean it's then not changing anything, because then we multiply and we will do that. So that means we've tinted the albedo, and so these ones that used that, we link them up instead to the tinted version. So now we can tint the textures if we need to, which is always a really handy thing to make sure you've got available. It's very, very commonly used, so good to make sure we've got support for that. So what this will let us do then is we go back to our scene, and with this, let's set leave it at that, and we'll start it dissolving. So you can see there, the weight, that will control how much it's weighting the edge color versus the albedo one, so we can see that. If we applied an existing tint, we can see, then we have our existing tint in there, and that is going to, depending upon the blend mode that we're using, that'll interact differently with that edge color. So it's going to be down to how we have that sort of set up is going to affect how that impacts with that edge color, because we did use a blend option there. Where it's doing a burn setting. So you will get different colors there, but it's going to be down to the particular operator. We could change the operator that is being used. So we do at the moment, it's using burn, but we could change this to simple things like multiply is a fairly common one. That's going to slightly then change the appearance of that. And then that's going to mean when we're working with this, changing that color, still going to have an impact on what our edge looks like there, but it's going to be a little bit different. So that's something to experiment with, see sort of how you want that to be working as far as the tint and the edge color there of what you want that to look like. But that gives us our reusable shader that will work for our setups here. Gives us a really sort of cool effect there for it. And then if we wanted, we could have that be moving though moving generally is not something we overly want with it. It does tend to look a little bit weird, so we probably wouldn't move it a lot. You could do very, very slow movement though, is an option there for it. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, you'll find it available up on GitHub, and the link to that's in the description below. If you've got any questions, chuck in a comment. If you found the video helpful, do chuck in a like and subscribe. Really helps out, really appreciated. And if you're looking for other ways to support the channel, then I do have a Patreon, and you'll see there's a link to that in the description below as well. But until next time,